Buyers in the luxury SUV market are normally forced to make a choice. You either get a soft, comfortable ride that falls apart the second it leaves the pavement, or you buy a rugged, heavy-duty truck that shakes your tires and your teeth on the highway. This custom wide-body Toyota represents an attempt to bridge that gap by applying heavy-duty structural changes to a luxury platform. Look closely at the grille geometry in this diagram. As incoming wind hits the fascia, it induces vortex generation, creating controlled, spinning pockets of air. This channels cool oxygen into the engine bay while reducing aerodynamic drag. Moving to the rear three-quarter profile, we see the physical scale of the build. Notice the wide body kit flaring out over the tires, the quad exhaust pipes set into the lower diffuser, and how the black metallic finish highlights the density of the footprint. Those expanded body panels are a structural necessity. They house a significantly widened track width. Pushing the wheels further apart from the center line lowers the vehicle's center of gravity, a mechanical requirement for keeping a heavy, lifted chassis stable at highway speeds. The visual aggression is a byproduct of these physical requirements. Every exterior curve exists to keep the vehicle anchored to the pavement when moving fast, resulting in a design born from functional stability. Drilling down from the chassis, the same logic applies to the microtextures. The wheel rims are forged from a specialized alloy, prioritizing a high strength-to-weight ratio to withstand heavy impacts that would crack standard aluminum. Wrapped around those rims is a dual-purpose tire tread geometry. The rubber blocks are staggered so they can bite into loose dirt and gravel without generating the loud, rhythmic road noise common on asphalt. Even the metallic paint is applied with a calibrated reflective index. The top coat is formulated to bounce light in a way that emphasizes the structural creases along the doors and fenders. When you look at the complete silhouette in a full rotation, the intent is clear. From the forged alloys to the paint chemistry, every millimeter is designed to deliver heavy-duty capability within a refined package. Inside the cabin, the priority shifts from exterior force to isolation. The interior acts as a fortified cell, built to detach the driver from the physical noise and vibrations of the environment outside the glass. This radar chart plots the cognitive load placed on a driver. A standard SUV scatters controls, increasing the mental effort required to operate the vehicle. By applying cognitive ergonomics, this layout groups tactile dials and screens where the driver's hands and eyes naturally rest, reducing distraction during high-stress maneuvers. Surrounding that interface are thick acoustic dampening materials that block engine drone, paired with low Kelvin ambient lighting designed to reduce sensory fatigue. This interior design prioritizes cognitive bandwidth over traditional aesthetics. It keeps the driver focused on navigation and surface conditions rather than fumbling with menu layers or fighting cabin noise. Launching this much mass requires immediate kinetic transfer. When the accelerator is pinned, those staggered tread blocks lock into the asphalt, translating engine torque into heavy forward momentum. As the speedometer climbs, the vortex-generating grille goes to work. It slices the incoming air, suppressing the wind roar and drag that would otherwise buffet a high-profile exterior at highway speeds. Beneath the chassis, an adaptive air suspension system constantly reads the road surface. It softens the compression on the wide-body track, neutralizing potholes and uneven pavement before those vibrations reach the cabin. The result is a heavy, armored machine that maintains its composure on the highway. It provides stability and silence at high velocity, proving it can operate as a specialized pavement cruiser. But the pavement is only half the test. In a high-heat desert, the physical demands change. Loose, shifting sand acts like a fluid, fighting to swallow the heavy tires and rob the chassis of traction. This schematic shows the drivetrain from below. Watch the power distribution arrows. The system uses torque vectoring to detect which wheels are slipping in the deep sand and instantly reroute engine power to the wheels that still have grip, maintaining constant forward momentum. In a dense jungle, the resistance becomes heavy, viscous mud. Pushing through deep trenches requires the mechanical force to move thousands of pounds of steel through wet clay without bogging down. The elevated ground clearance keeps vital undercarriage components above submerged obstacles. Simultaneously, the wide channels in the tire tread spin fast enough to eject packed mud, clearing the rubber so it can bite into the earth again. Whether it is loose sand or deep sludge, the mechanical engineering takes over. It manages hostile elements that would damage the suspension or overheat the engine of a standard luxury vehicle. Look at the vehicle now. Coated in baked sand and wet jungle mud, the pristine aesthetic from the start of our analysis is gone, replaced by the evidence of its environment. Despite the stress, the chassis remains intact. The vehicle demonstrates that a single platform can hold a stable line on a high-speed highway and crawl through a jungle trench on the same set of tires. It proves that the gap between a luxury cruiser and an all-terrain vehicle can be closed through specific, data-driven